Hi guys, welcome to Mathematics Study channel. In the last class, we discussed about determinant. We have already finished exercise 4.1. Today, we are going to discuss exercise 4.2. Exercise 4.2. Here, question number 1 to 5 is using the property of determinant and without expanding, prove the followings. Here we use only properties, we cannot expand. Okay, we cannot expand the determinant, we only use the property and prove the followings. So question number 1 is solution. It is given, what is given? The determinant of a b c. Here a b c, not a b c, sorry, x y z, second column a b c, and third column is x plus a, y plus b, and z plus c is equal to 0. We are going to prove this equal to this. So solution, let a equal to determinant of this x y z, a b c, x plus a, y plus b, z plus c. Okay, now using property, how to use? Applying. You should write here applying. What we apply here? C3 tends to what? If we subtract C3, this is the first column, this is the second column, and this is the third column. This is C1, C2, and this is C3. So C3 tends to what? C3 minus C1. If we subtract third column from first column, then what we get? This is equal to what? First column is same x, y, z, and second column is same a, b, c, and third column C3 tends to C3 minus 1. C3 is what? C3 is x plus a minus C1. C1 is what? X. This is equal to a. Similarly, third column is in second row, third column is y plus b minus what we get? B, not b, sorry, y. This is equal to b, and similarly z plus c minus z equal to c. So we have a, b, c. Okay. In property number 2, if 2 columns or 2 rows are identical, then the value of determinant should be 0. Here C1, not C1, sorry, C2 and C3 of the determinant are identical. So what we write? Are identical. So we can write, what we write? X, y, z, a, b, c equal to 0 as 2. So now we are going to solve question number 2. Question number 2 is, first we have to write, question number 2 is determinant of a minus b. First row is a minus b, b minus c, c minus a minus b, b minus c, and c minus a. Second row is b minus c, b minus c, c minus a minus b. And third row is c minus a minus b, and b minus c is equal to 0. We are going to prove this is equal to 0. So let a is equal to this, a minus b, b minus c, c minus a, b minus c, c minus a minus b. C minus A minus B, B minus C. We are use the property. So if we applying here, applying what we applying here, applying if we applying C1 tends to what? C1 tends to C1 plus C2 plus C3. C1 tends to C1 plus C2 plus C3. That means the value of C1, the first column, is equal to what? C1 plus C2 and plus C3. C1 is what? A plus B. Okay. C2 is B plus C. Right here B plus C. And C3 is what? C3 is C plus A. C plus A. Okay. C plus A. So C1 is what? Sorry. C1 is A minus B plus C2 is B minus C plus and C3 is what? C minus A. So this is plus and this is minus. Cancel plus minus cancel plus minus cancel. So this is equal to what? 0. So we get what we get? This is equal to, this is A minus B, sorry, this is 0 and this is B minus C. There is no sense in second and third row. C minus A. This is also 0 and this is C minus A minus B, and this is also 0, C minus A minus B. Okay, this is equal to 0. Why? Because in property 1, if all the elements of a column or a row are 0, then the value of the determinant should be 0. Since here, the first here, you write here C1, here C1, in C1, all the elements are 0. Okay, all the elements are 0. So the value of this is should be 0. Okay, clear? Now I am going to solve question number 3. Question number 3 is what? The question number 3 is determinant of first row is 2 7 65, second row is 3 8 75, and third row is 5 9 86 is equal to what? Equal to 0. We have proved this. How to prove this? So solution, let A equal to this. Let A equal to 2 7 65, 3 8 75, 5 9 86. Okay, this is 86. So applying, what we apply here? Applying what property we have to apply here? Applying C3 tends to C3. This is C3. Okay, applying C3 tends to, C3 is 65. No, C3 is 65. So if we subtract this minus 7 into what? Near to 65. 7 into, we know 7 into 9. 7 into 9 equal to 63. Okay, 7 into 9 into 63. Again 9 into what? Again 9 into 8. 9 into 8. 9 into 8 equal to 72. Okay, into 72, and 9 into 9 equal to 81. If we subtract this, then what do we get? That means C3 tends to C3 minus 9C1, 9C2, not C1, 9C2. Then what do we get? This is equal to, first column is same, 2 3 5. Okay, this is 7 8 and this is 9, and third column is, this is 65 minus 63 equal to what? 2. This is equal to 2. Here is 75 minus 72 equal to 3. Right here 3. Okay, this and here is 86 minus 81 equal to 5. Equal to 5. This is if we interchange the row and coulomb, then what we get? If we interchange row and coulomb, then what do we get? 2 3 5 2 3 5 7 8 9. Using what we have to use here? Using what is used? C2 implies and implies C3. Since C1 and C2 are identical, here C1 and C2 are identical. So here C1 and C2 are identical. Therefore 2 3 5, okay, 2 3 5 7 8 9 7 8 9 should be equal to 0. Why? Because two coulombs are identical. Is it clear? Now we are going to solve question number 4. Solution. Let A equal, what is that? A is determinant of 1 1 1. First coulomb is 1 1 1 and second coulomb is BCCA AB and third coulomb is A whole into B plus C, A whole into B plus C, B whole into C plus A and C whole into A plus B. This is the third coulomb. Okay, this is equal to 0. We are going to prove this is equal to 0. How to prove this? Very simple. This is equal to applying. We apply here sum of applying what we apply here. Very simple. This is C2. Okay, this is C3. So C3 tends to what we apply here? C3 tends to C3 plus C2. C3 tends to what? C3. This is C3. Okay, C3 AB plus AC. This is BC, no? So what we get? C3 tends to C2 plus C3. Okay. Then what we get? This is 1 1 1 and C2 is same, BC CA. This is AB and what we get? A whole into B plus C. That means AB plus CA plus B. C2 is what? BC. Then we can write what we can write? AB plus BC plus CA. Here also we write AB plus BC plus CA. Okay. Here also we write AB plus CA plus BC. That means AB plus BC plus CA. Is it clear? Now taking common. Now taking common, what we have to common? AB plus BC plus CA from C3 we get. If we taking common AB plus BC plus CA from C3, that means from third coulomb, then we have what we have? Taking common what? AB plus BC plus CA whole into 1 1 1 BC CA AB, and here if we taking common AB plus BC plus CA, then what we get? 1 1 1. In this determinant also C1 and C3 are identical. So what we write? This is equal to, we can write AB plus BC plus CA into 0. Since right here in the side between brackets, since C1 and C3 are identical. Is it clear? Okay, so this should be equal to what? 0. Now we are going to solve question number 5. So question number 5 solution. What is given? B plus C, Q plus R, Y plus Z, C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y equal to 2 into determinant of first column is A, B, C, second column is P, Q, R and third column is X, Y, Z. Then we are to prove this equal to this. So solution left hand side, take left hand side. What is left hand side? Left hand side is what? B plus C, first column B plus C, C plus A plus B. Okay, and second column is Q plus R, R plus P and P plus Q, and third column is Y plus Z, Z plus X and X plus Y. Okay, now we are going to prove 2 whole into first column ABC, second column what? PQR and third column is XY Z. Now we are interchanging the row and column. If we interchange the row and column by interchanging right here, by interchanging the row and columns, we have what we have. If we change the row and column, then what we get? First column is first row B plus C, C plus A plus B, Q plus R plus P plus Q, and third column is Y plus Z plus X plus Y. By interchanging the row and column. Okay, now applying what we have to apply, applying C3, what we have to apply C3. So we are going to find 2 whole into ABC. Okay, so using C3 whole into C3 minus, C3 is what? C3 is A plus B minus what? C minus, this is A plus B, this is minus, suppose C1 is B plus C. Okay, B plus C and plus C2 is C plus A, then what we get? A plus B, this is minus B, this is minus C, this is minus C and this is minus A. Then plus A minus A cancel out, plus B minus B is cancel out. So we have what we have? Minus C. Okay, we have minus 2C. Okay, so we write here, this is minus 2C. In this we have minus 2R, and in this row we have what we have? Minus 2Z. So right here C3 tends to C3 minus C1 plus C2. Then what we get? First column is same, Q plus R, Y plus Z, and second column is also same, C plus A, R plus P, Z plus X. Only third column is changed. In third column what we get? First one is what we get? Minus 2C. Similarly, C3 is P plus Q. Okay, P plus Q. This is minus Q minus R minus P. So this is P, Q cancel. Here we have minus 2R, and lastly we have minus 2Z. Okay, taking minus 2 common, common from C3 means third column. Then we have what we have, this is equal to minus 2 is common, okay? So we have B plus C, C plus A, this is only C, Q plus R, R plus P, this is R only, and this is Y plus Z, okay? Z plus X, this is Z, okay? So what we have? We have minus 2 into B plus C, Q plus R, okay? Q plus R, R plus P, and R, Y plus Z, Z plus X, hint R ki paisu, Z paisu. Now applying C1 using here, using C1 tends to what? C1 tends to, we are going to prove first element is what? First element is A, okay? So okay, C1 tends to what? C1 tends to C1 minus, C1 is B plus C minus what? Minus this C3. If we subtract this, then B plus C minus C, then this CC cancel, then what we have? B. Similar and okay, and C2 tends to what? C2 minus C3, C2 minus C3. That means C plus A minus C, then CC cancel, what we have? A. This is equal to minus 2, okay, whole into, this is what? C1 tends to C1 minus C3. That means B plus C minus C is B, okay? So this is what? This is RR cancel Q, and this is ZZ cancel Y. Here is CC cancel, we have A, here P, and here is X. Here there is no sense C, R, Z. Okay, what we have? B, A, C, Q, P, R, Y, X, Z. But we are to prove, what we are to prove? Equal to 2 whole into A, B, C. To A, B, C, no? So what we are to, by interchanging, using here, right here, using C1 implies and implies C2. C1 implies and implies C2. If we interchange C1 and C2, then in a property 2, if any pairs of row and column are interchanged, then this sign should be negative, okay? So what we have? Here is minus 2. So if we interchange C1 and C2, then here also another minus. So what we get? This is minus, minus is plus. This is A, P, X. This is B, Q, Y, and this is C, R, Z. Okay? Now if we interchange the row and column, then we get the results. So if again interchanging the row and columns, we get, what we get? This is equal to 2 whole into, first row is first column A, B, C. Second row is second column P, Q, R, and third row is third column X, Y, Z. This is the answer, okay? This is equal to right hand side. So I am now going to solve question number 7. Solution. Question number 7 solution. Prove that determinant of minus A square, first column is BACA, AB minus B square CA, AC, BC minus C square equal to 4, A square B square C square. So first we take left hand side. Left hand side equal to what? It is given here minus A square, first column minus A square BACA. minus a square ba ca. Okay. Second column is ab minus b square cb. ab minus b square, and this is cb. And third column is ac bc minus c square. This is left hand side, and we are going to prove we are going to prove for a square, b square and c square. Now taking common, what we have to common here in first, this is b square, sorry, and this is the first row, and this is the second row, and this is the third row. In first row, with taking common, what we have to take common? A is common, because in every element A is here. So taking common in the first row A, in the second row we have to take common B, because in every element B is multiplying, and in the third row we take common C. So taking common A, B and C from R1, R2 and R3 respectively. If we taking common respectively, then what we get? This is common, okay? This is A, B, C. A, B, C. Taking common, no? A, B, C is common. Then A, B, C common. Here is minus A, and this is only B, and this is what? C. Here is A, B. Taking B is common in second row. Then here is A minus B, and this is C. Here is A, C is common now, then B, this is minus C. So taking common A, B, C from R1, R2 and R3, then we have this. Okay? Again we taking common factor A from C1, and this is the C2, and this is C3. Similarly, we take common B. Here A, here is B, and here is C. Again, we take common what? Again, we have to take common A from C1, B from C2, and C from C3. Then again taking common small a, B and C from C1, C2 and C3 respectively. Then we have what we have? This is equal to ABC falling to ABC. Okay, ABC. This is equal to what? If we take common minus, not minus A, then here is minus 1. This is minus 1, 1, 1, and this is 1. This is minus 1, 1, and this is 1, 1, minus 1. Now, if we expanding along, this this is equal to A square, B square and C square. Again you use here property, or we expand this. Again if you use the property using R1 tends to R1 plus R2, we use here property using R1 tends to what? R1 plus R2, then and R2 equal to what? And R2 equal to what? R2 minus, this is R2 tends to R2 minus R3. Okay, R3. Then we have this is equal to A square, B square, C square. This is equal to what? R1 means what? R1 is R1 plus R2. Okay, this is R1 tends to R1 plus R2, then minus 1 plus 1 0. Okay, this is the R1 R2. So this is R minus 1 plus 1 0, 1 1, this is also 0, and this is 2. 1 plus 1 is 2. And R2 is what? R2 is R2 minus R3. R2 is R2 minus R3. That means 1 minus 1 is 0. Minus 1 minus 1 minus 1. That means minus 2. Here is R2 is 2 1 minus 1 minus, not minus, this is minus 1. Okay, so minus 1, this is plus 2. So third column is same, 1 1 and minus 1. Now expanding along with R1, this is equal to A square B square C square. If we expanding along with R1, then these two elements should be 0. Then what we get? 2 whole into what? 2 whole into what? Into 2 whole into, by cancelling by this row and this column, then what we have? We have 0 into 1 0, minus 1 into minus 2 is minus 2, minus minus plus 2. Okay, so what we have? We have 2 into 2 is 4. Okay, 4 A square B square C square equal to right hand side. This is the answer. Now we are going to prove question number 8.1. The question number 8.1 is what? First column is 1 1 1, A B, second column A B C, and third column is A square B square C square equal to A minus B, B minus C, C minus A. We are to prove this equal to this. Okay, so first let, this is delta और है, कोई भी चलेगा. Let delta equal to 1 1 1 first column, and second column is A B C, and third column is A square B square C square. A square B square C square. So operation हमें की, what operation we have to use here? The operating what? Using R1 tends to what? R1, using R1 tends to R1 minus if we subtract, what we are going to subtract? R1 minus R3. Okay, and R2 tends to R2 minus R3. R1 means first row, this is the first row, and this is the second row, and this is the third row. This is R1, R2, and this is R3. So first we are operating this operation. So this is equal to what? R1 tends to R1 minus R3. That means 1 minus A square. First one is 1 minus A square, and similarly this is, sorry, R1 minus R3. No, so R1 minus R3. This is R1 and this is R3. So 1 minus 1 is, this is 0. Okay, sorry, this is A minus C, and here is A square minus C square. So R2 is what? R2 minus R3. That means this is also 0. Here is B minus C, and here is B square minus C square, and there is no change in third row because we cannot any operation in third row. So third row is same, 1 C and C square. If we are taking common A minus C from R1, B minus C from R2, and not end. Okay, now taking common what we are going to take common? Taking common A minus C and B minus C from R1 and R2 respectively, we have what we have. So this is equal to taking common A minus C whole into B minus C. Determinant of this is 0, this is 1, 0, 1. Here is, since a square minus c square, that is a square minus b square formula. So a square minus b square is what? After break the formula, a plus b will into a minus b. But we are taking common a minus c. So remaining is what? A plus c only. Okay? A plus c. So this is also 0, 0. And this is 1. This is, here is b plus c. And third row is same. 1, c and c square. 1, c and c square. Now this is equal to what? A minus c whole into b minus c. Now expanding along with what? First Coulomb. Expanding along with C1. Expanding along with C1, then first two elements are 0. So these two are 0. So into what? 1 whole into what? By cancelling by this row. This Coulomb and this row. Cancelling by this. Then remaining elements are what? Remaining are this one. So remaining is what? This is 3, 1. Okay. So sign is positive. So 1 a plus c. Here is 1 b plus c. This is equal to a minus c whole into b minus c whole into what? This multiplying with this b plus c minus 1 whole into a plus c is minus a minus c. So this is equal to a minus c, b minus c, and this c and this c are cancel out. Then what we get? B minus a. Okay, but we are going to prove, what are going to prove? A minus b, b minus c, and c minus a. Now if we taking common minus from this and this, then minus is plus. So what we have to write? This is a minus b, okay, and this is b minus c is same, and this is also c minus a, equal to right hand side. Now we are going to solve question number 8.2. Question number 8.2 is it is given first row is what? It is given first row is 1, 1, 1, second row a b c, and third row is a cube, b cube, c cube. And we are to prove a minus b whole into b minus c whole into c minus a whole into a plus b plus c. So first it is let delta equal to what? Delta equal to this one. First row is 1, 1, 1, 1, 1, 1, and second row is a b c, and third row is a cube, b cube, c cube. Okay. Now what operation we have to done here? The operating C1, operating here, C1 tends to what? C1 tends to this minus this. Okay. C1 tends to C1 minus C3, and C2 equal to what? C2 means second Coulomb. This means b minus c, b cube minus c cube. So we write what? C2 minus C3. Performing this, then what we get? Using this, then first Coulomb is this should be 0. Why 0? 1 minus 1 is 0. Okay. So second Coulomb, this is a minus c, and this is a cube minus c cube. A cube minus c cube. So here is what? C2 tends to C2 minus C3. 1 minus 1 is 0. And b minus c, here is b minus c, and here is b cube minus c cube, b cube minus c cube. And third row is same, because we cannot done any operation in third Coulomb. Then 1 c, and this is c cube. Okay. If we taking common a minus c, because we know a cube minus b cube formula, we know a cube minus b cube equal to what? A cube minus b cube formula is a minus b whole into a square plus ab plus b square. Okay. This is the a cube minus b cube formula. So we break this formula a cube minus c cube. So what taking common right here, taking common what we have to take common a minus c. Taking common a minus c from c1 and b minus c, and b minus c from what? B minus c from c2. Then we have what we have. If we taking common, then we have what we have. This is 0. Okay, take common a minus c. This is 1, and here is what? Here is a square plus ac plus c square is remaining. Okay, if we break this formula, then a minus c is common, no? So right here, sorry, this is common, no? Sorry, this is equal to what? This is equal to taking common a minus c. So right here a minus c whole into what? B minus c into what? This is 0, this is 1, and this is what? A square. After break this formula, then what we remaining is a square plus ac plus c square. But here is also 0. Okay, and this is b minus c is 1, taking common b minus c. Then here is also what? B square plus bc plus c square, and third column is same. This is 1 c and c cube. Now expanding along with r1. Now if we expanding along with r1, then this is equal to a minus c, b minus c, and this one and this one are 0, no? So the value should be 0. Okay, there is 2 into 1. So 1 is what? This is the first row, and this is the third column. So sign is positive. Why? Because the sign of this is what? This is A13. No, A13 means I is 1 and J is 3. So 1 plus 3, 4. 4 is a even number, so sign should be positive. So how to get this? Expanding by cancelling first row and third column. Then remaining elements are what? 1 into this. 1 into b square plus bc plus c square. 1 whole into what? B square plus bc plus c square, and minus this into this a square plus ac plus c square. That is minus and multiply minus a square minus ac minus c square. So this is equal to a minus c whole into b minus c whole into what? If you write here b square minus c square, okay, b square minus c square, and this b square minus c square, b square minus c square. Okay, this is b square plus bc plus c square. This is a square. C square is cancelled. This is plus and this is minus. So you write first, we have to write b square minus a square, and here is what? Here is plus. Okay, plus what is here is bc minus ac. So write here bc minus ac. This is equal to, we have bracket. So this is equal to what? A minus c whole into b minus c. Break this formula. This is b minus a whole into b plus a. Okay, if we take common here, what we have to take common here? If we taking common c, then plus c is common, then we have b minus a. So this is equal to a minus c whole into b minus c. Now taking common b minus a, then remaining is what? Here is b plus a, remaining is plus c. So this is equal to what? If we taking common minus from this and this, then what we get? A minus b, and this is b minus c, this is c minus a falling to A plus B plus C. This is equal to right hand side. Is it clear? ভিডিওটো কেনেকুৱা লাগিছে কমেণ্টত জনাব যদি ভাল লাগে তেন্তে লাইক আৰু শ্বেয়াৰ কৰিব আৰু এনে ধৰণৰ নতুন নতুন ভিডিঅ' পাবৰ কাৰণে চেনেলটো ছাবস্ক্ৰাইব কৰিব